Hi guys, greetings of the day. I Vijay Vardhan. Welcome you to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my channel yet, kindly subscribe. Also click on bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now let's start the session number 22, which is based on axial piston motor, a bent axis design. An axial piston motor, which is nothing but a bent axis design, is similar to bent axis pump which we have discussed earlier in previous sessions. In this case also, the cylindrical block and the shaft are mounted at an angle to each other and the reaction is again as the driven shaft flange. And the figure shows the fully assembled 3D view, schematic diagram and photograph of a bent axis which is nothing but an axial piston motor. And coming to the formula for the torque and the power developed by the motor is as same as variable displacement, that is called as a Schwarz plate design piston motors, which we have discussed in one of the previous sessions. Next, coming to radial piston motor. In radial piston motors, the piston reciprocate radially or perpendicular to the axis of the output shaft, where the figure A shows the basic principle of operation of radial piston motor. And the radial piston motors are low speed and high torque motors. Upon working, when the high pressure oil is introduced into the cylinder, the piston will be pushed outward. For this action, the cylinder block containing the pistons will rotate and hence the output shaft of the motor connected to the cylinder block. Whereas figure B shows the three pistons fitted in a cylinder block and their three different positions. As the cylinder block rotates along with one of the pistons, pressure oil is introduced into the bore of piston, thus creating torque of the cylinder block and hence continuous rotation is generated in the motor. The rate at which the pressure fluid is introduced or pumped into the cylinder determines the speed of the motor. Radial piston motors may be either fixed or variable displacement type. Variable displacement can be achieved by changing the length of the piston stroke. The length of the piston stroke is controlled by eccentricity or half center of the cylinder block with respect to the rotor. Upon the applications, the radial piston motors find their applications in marine wrenches and the ruders, construction equipments, and high power industrial machines, etc. Then coming to theoretical torque, power, and discharge. Actual torque developed by hydraulic motors are less than the theoretical torque that the motor should develop. This is due to frictional losses, and the theoretical torque is the torque developed by a frictionless hydraulic motor. Theoretical torque and hence the theoretical power may be computed as follows. The theoretical torque, which will be calculated based on the formula Vd into P, usually in Newton meter per radian, where TTH is Newton meter per radian. Vd is nothing but the theoretical discharge in meter cube per revolution. P is the pressure of the oil entering the motor in Newton per meter square or in pascals. It can be observed from the above equation that the theoretical torque is a function of pressure and the volumetric displacement Vd. Then coming to theoretical power, it will be computed by the formula TTH into N, where N is the speed of the motor. Then coming to the theoretical discharge QTH, which will be usually calculated by Vd, that is volumetric displacement, into the speed of the motor, or it can also be calculated Vd into N by 60 to get meter cube per second. This is about the concept of theoretical torque, power and discharge. Next we are going to discuss on performance of hydraulic motors. The performance of any mechanical system depends on the precision of manufacture of its elements and maintenance of the close tolerances under the design operating condition. So also in the case of hydraulic motors, the hydraulic motor performance is also evaluated on the three efficiencies, namely volumetric efficiency, mechanical efficiency, and overall efficiency. Let us understand what is called as volumetric efficiency first. Volumetric efficiency of a motor is the ratio of theoretical displacement to the actual displacement. That is, actual displacement to run or rotate a motor is greater than the theoretical discharge due to leakage, and mathematically it could be equated like this: volumetric efficiency is equal to theoretical discharge to the actual discharge into 100, which will be usually in terms of percentage. Coming to the next type of efficiency, that is called as mechanical efficiency. The mechanical efficiency of a motor is the ratio of actual torque developed by the motor to the theoretical torque mathematically, T actual by T theoretical into 100 in terms of percentage. Coming to overall efficiency, the overall efficiency of the pump is the ratio of actual power delivered by the motor to the actual power delivered to the motor, and mathematically it can be calculated by the formula 2 pi into actual torque divided by 60 to convert it into per second, divided by P into Vd into 100 to convert it into the efficiency. And alternatively, we can calculate, that is, volumetric efficiency into mechanical efficiency will be the another formula to calculate the overall efficiency. Then coming to the next concept, that is called as advantages of hydraulic motors, which is as follows. Stepless variation in speed. This can be achieved by varied from 0 to maximum available in motor. A very simple adjustment controls the complete speed range. Then coming to explosion proof and requires no electrical connection except to hydraulic lines. And cable of sudden stop without damaging the mechanism. This can be achieved by using a check valve. Then coming to frequent stopping, starting and reversing can be achieved using a single 4-port 3 position, that is 4 by 3 directional control valve. And it is also suitable for drives in machine tools wherein controlled variable torque is desired, as in case of paper winding, and also very low power to weight ratio, and can be installed for an indefinite period without damage and very low starting torque. And coming to the application part, it could be used in pottery machines, it could be used in paper winding machine, and sophisticated machine tools such as CNC machines, drill rig, etc. Then coming to the different types of cylinders and their graphic symbolic representation, where you can see the figures and understand the graphical representations. That is, retraction by gravity, retraction by spring, telescopic retraction by gravity, like this, a double acting cylinder, the various condition, and the graphical symbolic representation where you can observe the same. Then you can see another things. Then coming to the hydraulic motors and their graphical symbolic representation for unidirectional motors as well as bidirectional and limited rotation and variable displacement, everything we can observe the figures over here. So by this, we have end up with the second module, and this is some of the few assignment questions which you can make a note, so that by learning this, you can confident that you have understood the concepts very clearly. So by this, the time allotted for the session has been completed, and thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in the session. Don't forget to like, share and subscribe. Have a great day. Signing off, Vijay Tavardhan.